morning children. The last class what we have discussed, let me have the quick recap of that. See children, we discussed about the Ohm's law and electric effect in series connection, that is equivalent resistance in series connection and equivalent resistance in a parallel connection. Afterwards we went to discuss about what is the electric shock and how it affects were discussed. What is the electric power? Kirchhoff laws, loop law and a junction law. What is a junction law? Kirchhoff laws, two laws together is known as a Kirchhoff laws, that is a junction law. Sum of the current into the junction is equal to the sum of the current leaving from the junction. This is known as a junction law. And loop law, the algebra sum of increase or a decrease in the potential difference across the conductor is equal to 0. According to law of conservation of mass, mass is neither increase nor decrease. Here also, sum of increase or decrease in the potential difference is equal to the 0. If 3 units are increased, 3 volts decreases. So, sum is equal to the 0. Total potential becomes a equal, that is a 0, is said to be a law of conservation of a mass. Till that we discussed, and 2 to 3 problems already solved. Problems are given in textbook based on a Kirchhoff laws. Equivalent resistance in series connection and equivalent resistance in parallel connection, that is 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. And R equals to R1 plus R2 plus R3. These two equations are most important. Derivation as well as small problem we are going to get on these equations in board exam. The derivations which we discussed related to the light, I said that Lenz formula, Lenz maker formula, mirror formula, derivations are not important, but formula is important to solve the problem. Here derivation as well as the problems are important. So next topic is the power. What is the power? To discuss the power, we need to discuss about a work. Work is nothing but when a force is applied, object moves at a distance, then work is said to be done. Here, work equals to Q into V. Who is applying the force? Potential difference. And on where? On charges. Charges are moving from one place to other place. So, W equals to Q into V. But what is a Q? And the rate of doing work is said to be a power. So, W by T is equals to Q by T. You know that Q by T is nothing but a I. So, we can write W by T is nothing but a P and Q by T is nothing but I, V, I. But you know the value of V from the Ohm's law. What is that? IR. Substitute that V value in this equation. P equals to, instead of V, I am writing it as a IR into I. IR into I is nothing but becomes I square R. And from the Ohm's law, you know the equation for I square, that is a V square by R into R. RR get cancelled. That becomes V square by R. This is the equation of power, and use this equation to solve the problems related to the events. And what is a EMF? Electromotive force. So, one problem he asked, let us consider an example to understand power consumption problem. A bulb is marked 60 watts in 120 volts. This means that if this bulb is connected to 120 volts source, it will be convert 60 joules of electrical energy into heat energy and a light energy. That is the in 1 second. That is the meaning of the watt. So, for making the bulb, you measure the resistance of the bulb from the relation P is equals to V square by R. R equals to V square by P. Substituting the values P and in the above equation. V is given as volts, that is given as 120. 120 into 120 by 60. 60 ones are 60 twos are. 120 into 2, 240. And R means resistance. Resistance is measured in ohms. That is a symbol of a ohms. Okay. Thus, the bulb marked 60 volts and 120 volts will offer a resistance of 240 ohms to flow the current through its normal conditions. The bulb is connected to the 12 volts of a battery. The consumption of the bulb is given by P equals to V square by R. V is nothing but 12. 12 into 12 by 240, that gives 0.6 watts. Okay. Since what is a small unit of a power? What is the watt, amma? Unit of a power. What is a power? Rate of doing work. See, rate of doing work. Rate means time. And work is nothing but Q into V by T. You know that Q by T is nothing but P by W by T is nothing but power. Q by T is nothing but a I into V. But Ohm's law, you know the value of P. V. P is equals to I as it is. V value is nothing but R I. That is I into I square by I square R. So what is the unit of power? Watt. And smallest unit of power is watt. And kilowatt is generally used in a power in a high, generally used to express power consumption in a bigger unit. Smaller unit is watts and bigger unit is kilowatt. 1 kilowatt is equals to how many watts? 1000 watts. And what are the units of watts? Are joules per second. You might have seen electric bill. There it is every time if you check the electric bill, it is written as kWh, kilowatt per hour. What is the meaning of kilowatt per hour? 1 kilowatt is equals to how many watts? 1000. And hour is nothing but you have to convert into second, that is 60 into 60. 3600 into 1000 gives 36.36 10 to the power of 6 joules. What do you mean by overload? Why does it cause damage to electric appliances? We frequently hear news about overload of current and damage caused by the overload. Electricity enters our home through two wires called lines. These line wires have low resistance and the potential between the wires is usually 240 volts. The two lines run throughout the household circuit to which we connect various appliances such as fan, TV, refrigerator, ovens, TVs, mixers, rice cookers, etc. All these devices in our house are connected at different parts between two wires. This means the electric appliances are in a parallel connection, and how much voltage it passes? 240 voltage. If we know that value of resistance of electric device, we can calculate the current passing through that. I is equals to V by R. For example, the current passing through bulb with the resistance of 240 volts is 1 amperes. Based on this electric device, it draws some current from the supply. Total current drawn from the main is equal to sum of the current passing through each device, junction law. If we add more devices to household circuits, the current drawn from the mains also increases. But what happens when a current increases greatly? To answer this, observe the value noted in the digital meter fixed at your home. You will notice that flowing values on the meters. Potential difference to 40 volts and current 5 amperes to the 20 amperes. This means lines that are entering through meter have the potential of 240 volts and the minimum and maximum current can be drawn from that is 5 amperes to the 20 amperes. The maximum current that is drawn is 20 amperes. When the current drawn from this is more than 20 amperes, overheating may cause a fire, and this is called overloading. If you switch on device such as a heater, the figure 32 draw current from the mains exceed the limit 20 amperes, and this causes the overloading. To prevent the overloading, we connect electric fuse to household circuit as shown in the figure. This arrangement, the entire current from the main must pass through the fuse. The fuse consisting of a thin wire of flow melting point. When the current is fused exceeds 20 amperes, the wire will get heated up and melts. The circuit then becomes open and prevent the flow of current to the household circuit. So the electric devices are saved from the damage that would be caused by overload. Thus we can say the householding wires and device by the fuses. The value of overload current amperes from the household current to factories. Okay, what is meant by overload? Already we discussed that light enters in our house through two wires. They are said to be lines, and through two lines how much amount of voltage it passes? 240 volts. And what is the current passed through the two wires, two lines? 5 amperes to the 20 amperes. 20 amperes is the maximum current passed through that lines. So if you see the diagram, you can understand better. Here from the 20 volts or 240 voltage, how much current it enters? 20. From the 20 we are using 6 amperes for TV, 5 amperes for the refrigerator, and 2 amperes of for bulb, 4 amperes for fan. Here 6 plus 8 14, 14 plus 2 16, 16 plus 4 20. And if you want to connect a heater which exceeds our limits, and this cause the overloading and start burning. To avoid that, a fuse is introduced, or fuse is fixed in that. What is a fuse? It melts with a low melting point. A metal which melts with a low melting point is said to be a fuse. When we connect a fuse, due to overloading, what happens? The metal starts melting and disconnect the switch. In this way, current supply is put off. So we can save our electric appliances by using or introducing the fixed fuse in a circuits. Okay, and this is said to be a overloading. Behind the limit, it exceeds the limits. 20 amperes of current must enters into the house, but it's exceeding the limit. If it exceeds the limits, then it is said to be a overloading. To avoid the overloading, what should be connected in the circuit? Fuse. What is a fuse? It is made up of a metal, but it starts melting with a low melting point. So with a less current, it starts melting. When it melts, it creates the gap. Then the circuit is breakdown. When a circuit breaks down, the current supply stops. So in this way, we can save our electric appliances from the overload. What do you mean by short circuit? Why does a short circuit damage electric wiring and devices connected to it? So what is meant by short circuit? You have to think and answer. With this, we completed our electric current. That is in the form of a 9th lesson. See children, few lessons, few topics from the lessons are deleted. So that topics, I feel that whatever the lessons we covered till now, we have the in the syllabus only. So the topics which we did not cover, the carbon and compound, they said that few topics are left. So this is your actual portion till the 9th. That's why I went to the 11th lesson also, which is there in the portion. The 8th and the 10th, few topics are taken out and few are there. 8th, 10th and 12th. 8th, 10th and 12th. So whatever the topics it is given, just I will go with the topics, but don't stress much on that. I'll tell the lessons and topics also, don't stress much on that. So first lesson, second lesson, third, fourth are there, fifth is few topics are taken out, sixth is there, seventh, eighth, few topics are taken out, ninth it is electric current complete, it is there, 10th taken out, and 11th it is there, principles of metallurgy, 12th. So my duty is left, what is that? I have to give the notes for that. I will make a PDF, I will send through WhatsApp group question answers simultaneously, the lesson also goes. Please children, complete your classwork because you have to write your essay 1 in the month of January. 1, 2, 3 lessons I gave the notes, and atomic structure also gave the notes. What is left? 4th lesson is left, I have to give the notes for that. Metallurgy I will send the PDF. 4th lesson also I will send a PDF, complete notes. I will give few answers only, and few answers you have to read with your own. Okay children, whatever the questions which are I will feel most important will give, remaining you can read from your workbook or from the textbook. But complete your classworks, project and activities also. The FA is going on, concentrate on that. And if you have any doubts, you can ask through WhatsApp only. Okay, ma? With this, we completed our 9th lesson, that is electric current. What we have discussed that in electric current, what is electric current, what is potential difference, what is EMF, and what is the Ohm's law, what is resistance, how we can satisfy the Ohm's law, ohmic conductors, non-ohmic conductors, voltage, power, overload, short circuits, effect of resistance in series connection, that is the equivalent resistance series, equal resistance in a parallel connections. All these topics we have discussed. What is electric current? I is equals to Q by T. What is a Q? Charges. Number of charges flowing for any cross section in a unit time, that is 1 second, is said to be electric current. And current is measured in amperes, measured by ammeter. And always ammeter is connected in series. What is the potential difference? Energy required to move the electron from unipositive charge to one place to the other place is said to be a potential difference. And potential difference is measured in volts, measured by voltmeter. EMF, electromotive force, chemical energy required to move the electrons from one place to another place is said to be electromotive force. And what is the Ohm's law? V is equals to IR, that is V is proportional to I. Potential difference across the conductor is directly proportional to the electric current passing through it at constant temperature. And V is proportional to I. From that we remove proportional symbol. To remove the proportional symbol, we need to introduce a constant. What is that constant? V is equals to IR. R is a constant. R is known as a resistance. And resistance are measured in ohms. What are the factors which affects the resistance? Length of the resistor, cross-sectional area, nature of the material. By using that, we got equation, that is R is equals to PL by A, where P is known as specific resistance or resistivity. Okay. Next comes to the ohmic conductors which obey the Ohm's law said to be ohmic conductors, which does not obey the Ohm's law said to be non-ohmic conductors. In ohmic conductors, metals are ohmic conductors, non-ohmic conductors, semi-metals, gaseous are non-ohmic conductors. And we discussed about the graph, how to plot the graph, how to draw that graph also. The next topic is about the Kirchhoff laws. We have the two laws, junction law, loop law. What is the junction law? The sum of current coming into the junction is equal to the sum of the current leaving from the junction. And this is known as a junction law. And what is a loop law? Algebra sum of increase and decrease in the current. Sum of current increase and decrease in the current is equal to the 0, according to law of conservation of mass. This is known as a loop law. Both the laws are known as a Kirchhoff laws. And what is power? Rate of doing work. P is equals to V into R is said to be a power. Use this equation for to supply the power. 240 volts is nothing but a voltage of the current is entering into the house, and that is the potential difference. And to the two potential difference, what is the amount of current enters into the house? Minimum is 5 amperes, maximum is 20 amperes. If we connect all the electric appliances at different points, if we exceed that 20 amperes of current, it is said to be a overloading, and overloading damages our electric appliances. To avoid that, a fuse is connected in the circuit. When a fuse is connected due to overloading, it submits. It starts melting, and when it starts melting, what happens? It disconnects it, and we can save our electric appliances due to shortcut of a power, and save our electric appliances. These notes I am not going to give now because it is not there in the essay 1 exam. So I will send from second onwards to 2 videos. I will send. One is a PDF, other is your lesson. So PDF you have to write your notes. Okay children, this Thursday and Friday also I am going to send the PDF through WhatsApp only. Thank you, children.